Okay guys, here's page 4 of the Unit 3 review packet. This is for regular and honor, so take a look. Let's start. So skill 8B says use the image to determine which lines, if any, are parallel, justify your answer. So we want to cover up all the information with our hand that we don't need. So angle 2 is in this intersection, angle 4 is in this intersection. In class we used a highlighter to highlight our relevant transversal, which is M, but since we have multiple problems, I'm not going to, but you might want to on your paper or redraw the picture multiple times. So M is going to be our relevant transversal. These two lines here are going to be our coplanar lines, and if one of our rules works, then we know these two lines will be parallel. Well, 2 and 4 are corresponding angles. Corresponding angles are indeed supposed to be congruent, so we can say yes. So again, these two lines, lines A and B, and I'll write that over here so it's easier to see too. Those two lines, lines A and B, are going to be parallel because of the converse, we're proving lines are parallel, of the corresponding angles postulate. So A is parallel to B. Why? Because of the converse of the corresponding angles postulate. Great, let's move on. Angle 1 and angle 6. Well, angle 1 is in this intersection, angle 6 is in this intersection. Well, wait a minute. When I cover that up, I only see two lines that intersect. There's no lines that could possibly be parallel when we cover up everything that we don't need. So no lines are parallel here because 1 and 6 are both in the same intersection. Okay. 2 and 11. Well, 2's here, 11's here, so I'm going to cover up the intersections I don't need. My relevant transversal is this line A. Let's see if our rule works. Well, 2 and 11, it says, are congruent, and they should be. They're alternate exterior angles. So we can say line L is parallel to line L because, oopsies, the converse of the alternate exterior angles theorem. My alternate exterior angles are congruent, therefore we can say my lines are parallel. So converse of alternate exterior angles theorem. Good. Okay, 5 and 10. 5's here, 10's here. Those are alternate interior angles. They should be congruent because if my lines are parallel, but we're trying to prove if they're parallel. So 5 and 10 are incongruent. That means we can use the converse. We can say because my alternate exterior angles are congruent, my lines M and L will be parallel. This is the 5 and 10. So the converse of alternate interior angles theorem. Okay, last one. We have angle 7 and angle 8. Okay. Well, yes, 7 and 8 should be supplementary because they form a linear pair, but I only see one intersection. That's not enough to prove that any lines are parallel. The other lines can be doing whatever they want, and those two would still be the same, or would still add up to 180 degrees. So since we only see one intersection, we can't prove that any lines are parallel, so none of them. So I'm just going to highlight really fast which lines were parallel or if there were any, and then you can look at the explanation afterwards. Okay guys, let's move on to our proofs. So we have skills 8C through D, which is about completing proofs. C is more about filling in blanks, or the reasons if we give you all the statements, and then D is about doing more of both sides. And so I ran out of copies of the back of the regular, so this is the honors one, so this bottom proof has some stuff missing, but I will help you fill in both sides. So let's start with A. It says prove the alternate interior angles theorem. Now, something we talked about in class is if we're proving one of the theorems that's on our reasons for proof list, we can't use that as a reason, and we can only use postulates and theorems from last unit. So let's make a list of what we have. Last unit, we had the linear pair postulate. Okay. So last year we had the linear pair postulate. Last unit, we also had the vertical angles theorem. Since it's from last unit, we can use it. So vertical angles theorem. This unit, our only postulate was the corresponding angles postulate. Now, we're not going to use it for this proof right now, but the only other one we can use as well is the converse of the corresponding angles postulate. Now, remember, for this proof, because we're proving one of our new theorems, one of the ones that's on the list, the name is actually on our purple paper list, we can only use postulates and theorems from previous units. So what we're really trying to do is we're trying to say, okay, we know our lines are parallel, so can you show me that 2 and 6 are the same? And we need to get from that 4 and 6 are the same size, that they're congruent, that their measures are equal. We need to find a way to get from 6 to 4 only using these things. Well, I need to jump from 6 up to this intersection, and the only one of these that lets me jump to this intersection is the corresponding angles postulate. It says that 6 is congruent to 2. So we were given that the lines are parallel, and because the lines are parallel, these are going to be congruent by the corresponding angles postulate. But we don't want to get from 6 to 2. We want to get from 6 to 4. Well, we've made it to 2. Can we get from 2 to 4? Yep, we can say those are the same because of the vertical angles theorem. So we kind of have a train. We got from 6 to 2. Then we got from 2 to 4. By the transitive property, since remember we got from 6 to 2, 2 overlaps, then we went to 4, we can say that 6 and 4 are going to be the same. That's the transitive property. And in this case, it's a property of congruence because we have a congruent sign. I shouldn't do that because it looks like an equal sign. Okay, that's our first proof. Let's move on. Actually, I want to skip this second one for now. There's going to be, here, I'll just make the key for it, but I don't really want to talk about it during this video. We can talk about it in class. I don't care for this proof for a couple of reasons. So let me clarify. It's not a bad proof. The thing is we just talked about how to prove one of our new theorems, we can only use this list of things. And in this proof, we're using things that are on the purple paper sheet, like the same side interior angles theorem. The reason why is we're trying to prove something totally new. So for instance, that angle 1 is congruent to angle 3. Well, the only way we can get from here is from jumping from this intersection to this one and this one to here, or for jumping down and then going across. So I'm just going to leave it like this for now. Take a look and write it in, but we can talk about it more in class. The one I really do want to spend time on again is C. We're proving the converse of the same side interior angles theorem, which means we are only going to use postulates and then theorems from last unit. So that same red list that we have up here. So let's start by looking at what's given. We're given that the measure of angle 3 equals the measure of angle 6. That was given to us. We need to find a way to prove that these two lines are parallel. The only postulate that lets us prove things are parallel is the converse of the corresponding angles postulate. And in order to use that, I need to show that this thing here and this thing here are congruent. If we can show that those two are congruent, we can show that the lines are parallel. So let's see if we can do what we did in A to get to that point. So we know that 3 and 6 add up to 180 degrees. That's good. Well, we also know the lines aren't parallel, so I don't know that 3 and 7 are the same. But I do know that 6 and 7 are add up to 180 degrees because they form a linear pair. Okay. Now let's keep going. Now some of you have more reasons listed on here, some of you don't, but I'll walk you through both anyways. We needed to get to 3 and 7 being the same. Well, we have that 3 and 6 are supplementary. We have that 6 and 7 are supplementary. Let's take a look at this. 180 is equal to this. 180 is equal to this. Well, that tells me, oopsie, sorry guys, I threw my pen. That tells me that the measure of angle 3 plus the measure of angle 6 is equal to the measure of angle 6 plus the measure of angle 7. That's my transitive property. It's a property of equality because of that equal sign right there. Great, okay. Well, let's see if we can get to just having 3 and 7. Well, I have a measure of angle 6 on both sides. So if I subtract it away on both sides, I get the measure of angle 3 equals the measure of angle 7. We subtract it on both sides, so that's my subtraction property of equality. Okay. Well, in order to say that my lines are parallel, I need my corresponding angles to be congruent. Well, if their measures are equal, that means that we can state that the angles are congruent. That's the definition of congruence. ooh, wow, I can't spell, sorry. Definition of congruence. Or if you'd prefer, you can just put the congruent sign. Okay, we're so close. Now we have that these two angles are congruent. Since those angles are congruent, now I can make my conclusion that line L is parallel to line M. And I can say that because of the converse of the corresponding angles postulate. I know we haven't spent a lot of time yet going over proofs, so we're going to do that on the review day, which is next class. So I don't want you to stress out if you're not feeling great about it yet, but hopefully you've at least heard me go through A and C and are feeling a little bit better.